So in this video, let us look at very simple trigonometric equations. So there are three types of simple trigonometric equations. So let us go for type 1. So type 1 trigonometric equations look like sine theta is equal to sine alpha, cos theta is equal to cos alpha, tan theta is equal to tan alpha, cosecant theta is equal to cosecant alpha, secant theta is equal to secant alpha, cot theta is equal to cot alpha. So if you have equations of this form, these are called simplest trigonometric equations of type 1. Okay. For example, so if you have a very simple trigonometric equation, sine theta is equal to half. So how do we solve this trigonometric equation? Sine theta is equal to half, and you know this number half occurs when theta is equal to 30 degrees in the first quadrant, right? Sine theta is equal to sine 30 degrees effectively. Usually you will be given a number. You need to search for this angle from your knowledge of basic trigonometry. So sine theta is equal to sine 30. How do we solve this? So if I write theta is equal to 30 degrees and come out, that will not be the right answer, because sine theta will be equal to half, not just for one value of theta. It will be equal to half for infinite number of values for theta. So you need to give all the values of theta if I ask you the solution. So to understand this, first I'll draw the quadrant diagram for sine theta. So quadrant diagram for sine theta means quadrant diagram where you write the signs of the trigonometric ratio sine. So the signs of sine are plus, plus, minus, minus, right? So sine is positive in the first two quadrants, negative in the second two quadrants. Now sine theta is equal to half. You get one angle as 30 degrees. So this is one position of the ray where sine theta will be equal to 30 degrees. Now from the concept of allied positions, so if the corresponding sign for this position is equal to half, the corresponding sign for this position is also equal to half the mirror image position or the allied position. So if this is 30, this is 30, that means this angle is 150 degrees. So for 30 degrees as well as 150 degrees, for this position as well as this position, sine will be equal to half. For the positions in the third quadrant and fourth quadrant, sine theta will be equal to minus half. I want sine theta is equal to plus half. So I'll take these two positions as my required positions. So within one complete rotation, sine theta becomes half at two different positions. So the answers are theta is equal to 30 degrees as well as 150 degrees. Is there a nice way to write this? Yes, this is pi minus 30 degrees. So it will be easier to write in radian measure. So 30 degrees. So theta is equal to pi by 6, 30 degrees, and pi minus pi by 6, right? Pi is 180 minus 30 degrees, pi minus pi by 6. These are the two solutions in the first rotation. And in each rotation, I'll be going on getting two solutions. So if I want to write the solution in the next rotation, so this is 2 pi plus pi by 6, right? 2 pi plus pi by 6, and 3 pi minus pi by 6, and 2 rotations plus pi by 6, that is 4 pi plus pi by 6, 2.5 rotations minus pi by 6, that is, right, 2.5 rotations minus pi by 6, 5 pi minus pi by 6, 3 rotations plus pi by 6, 6 pi plus pi by 6, 3.5 rotations minus pi by 6, 7 pi minus pi by 6, so on. So these solutions go on. So the set containing all these solutions is called the general solution of this equation. So I am not trying to solve this example. I am trying to find a general way in which you can write the solutions. So what I want you to see is the pattern in this solution. pattern in these solutions. So do you see that there is a very nice pattern in this form of solutions? So pi by 6, 2 pi plus pi by 6, 4 pi plus pi by 6, 6 pi plus pi by 6. So if you have even number of pi's, you're getting plus. And if you have odd number of pi's, 1 pi minus pi by 6, 3 pi minus pi by 6, 5 pi minus pi by 6, 7 pi minus pi by 6. So if you have odd number of pi's, you're getting a minus. If you have even number of pi's, you get a plus, right? So is there some way in which I can write this in a single expression? So theta is equal to, what I write is n pi is not n pi plus or minus pi by 6, n pi plus minus 1 whole power n times pi by 6. So this minus 1 whole power n is a very tricky expression. This becomes plus 1 if n is even. So for all even numbers before pi, you're getting plus. So if n is even, minus 1 whole power n will be plus 1. So you get plus pi by 6. And if n is odd, minus 1 whole power n is minus 1. You get a minus here. So this is the general solution to the equation sine theta is equal to half. And if we extend the same logic to sine theta is equal to sine alpha, the solution for sine theta will be, sine theta is equal to sine alpha is n pi plus minus 1 whole power n times alpha. So here it is sine 30 degrees, so you got pi by 6. If this has been root 3 by 2, you get 60 degrees. So you have pi by 3 here. If this would have been 1 by root 2, you get 45 degrees here. You get a pi by 4 here. So n belongs to integers. So the general solution for sine theta is equal to sine alpha is nothing but n pi plus minus 1 whole power n into alpha. That's the pattern for sine theta is equal to sine alpha. And the same works for cosecant theta is equal to cosecant alpha, because the quadrant diagram for both these ratios looks same. But this solution does not work for this. Let us look at how things work for cos theta is equal to cos alpha. So now to analyze the solution for these type of equations, cos theta is equal to cos alpha, secant theta is equal to secant alpha, let us take an example again. So let us try to solve cos theta is equal to half. So let us try to solve cos theta is equal to half. What is the general solution for this equation? So now what we do is we'll search for this half. So for what value of theta in the first quadrant will cos be equal to half? So we have cos half. Half is nothing but cos of pi by 3, cos 60 degrees, right? So now let us draw the quadrant diagram for this. So what is the quadrant diagram for cos? Plus, minus, minus, plus. Cos is positive in the first and fourth quadrants and negative in these quadrants. Now corresponding to pi by 3, you're getting cos theta is equal to half. That means pi by 3 is one of the solution. So now what are the other positions of the ray where you get the same value half? So obviously if you get plus half for this position, you get plus half for this position also, which is the allied position. So which is minus pi by 3. So cos pi by 3 is also equal to half. Cos minus pi by 3 is also equal to half. Now these are the two positions which make cos theta is equal to half. So let me write the solutions. So the solutions are plus or minus pi by 3, right? And what are the other solutions? If I complete one rotation, 2 pi plus pi by 6 or minus pi by 6, right? So I can start with 0 and go for plus or minus pi by 6. After one rotation, plus or minus pi by 6, sorry, pi by 3. And after two rotations, plus or minus pi by 3. So on. Plus or minus pi by 3, 2 pi plus or minus pi by 3, 4 pi plus or minus pi by 3, so on. Right? So now, once you have these solutions, you need to think about a general way in which you can write these solutions. So this pattern goes, and you can also write minus 2 pi plus or minus pi by 3. So you can complete one rotation in the clockwise direction. Minus 2 pi plus pi by 3 minus pi by 3, right? So you can go on to the negative side also. So if you observe these solutions, is there a nice way to write these solutions? So I can see that whatever numbers occur with pi this time, all those are even numbers. Odd numbers are not even visible to me. So theta is equal to, can I write it as 2n pi? Even multiples of pi can be written as 2n pi. So I always have plus or minus pi by 3 for everything. So 2n pi plus or minus pi by 3. So cos theta is equal to half implies theta is equal to 2n pi plus or minus pi by 3. So this is the general solution to the equation of the form cos theta is equal to cos alpha. So instead of pi by 3, if you have alpha, so instead of pi by 3, you get alpha here. So what is the general solution for equations of this type? Cos theta is equal to cos alpha. Theta is equal to 2n pi plus or minus alpha. So you need to remember these expressions. Now let us go to the third equations. Tan theta is equal to tan alpha and cot theta is equal to cot alpha. So to understand these equations, let us take an example. Let us try to solve tan theta is equal to 1. Let's try to solve tan theta is equal to 1. So now we know that 1 can be written as tan of 45 degrees, that is pi by 4. So now let us draw the quadrant diagram for tan theta. So we know that tan is positive in the first and third quadrants and negative here. So now we know that tan theta is equal to 1. Theta is equal to pi by 4 is being satisfied. So corresponding to the position of the ray, which is pi by 4, this equation is getting satisfied. Now what are the allied positions of this ray which makes tan theta is equal to plus 1? Because tan is positive in the first and third quadrants, you need to go to this allied position, right? If you go to this allied position, you get tan theta is equal to minus 1. And in the fourth quadrant also tan theta is equal to minus 1. So these are the two positions of the rays which maintain tan theta is equal to plus 1. So how can I write these solutions? So first solution is pi by 4. The next solution is 180 plus pi by 4. Pi plus pi by 4. The next solution is 2 pi plus pi by 4. The next solution is 2 pi 3 pi plus pi by 4. So I hope you're able to see the pattern here. So pi by 4, pi plus pi by 4, 2 pi plus pi by 4, 3 pi plus pi by 4. You can also have negative values. Minus pi plus pi by 4, minus 2 pi plus pi by 4, so on. Minus pi plus pi by 4, minus 2 pi plus pi by 4, so on. All these are solutions to this equation. So is there a general way to express all these solutions? So I can write theta is equal to, so you can see all integer multiples of pi are being seen here. So you have n pi. This time you don't need even multiples, you need all multiples. And with each of them you just have plus pi by 4 here. So I can write the general solution of tan theta is equal to 1 as theta is equal to n pi plus pi by 4. And if you have pi by 4 here, pi by 4 appears here. So if you have another angle alpha here, that angle appears here. So tan theta is equal to tan alpha implies theta is equal to n pi plus alpha. So theta is equal to n pi plus alpha is the solution to the equations of this type. So sine theta is equal to sine alpha, cosecant theta is equal to cosecant alpha implies theta is equal to n pi plus minus 1 whole power n times alpha. For cos it is 2n pi plus or minus alpha. For tan it is n pi plus alpha. So these are the three things that you need to remember in type 1. So let us try to summarize this and take some examples. So to summarize this topic, so in simplest equations of type 1 have three subtypes. First type is sine theta is equal to sine alpha or cosecant theta is equal to cosecant alpha. If you have equations of this form, the solution for this equations look like theta is equal to n pi plus minus 1 whole power n into alpha, and that comes from this quadrant diagram. And the second equations of the form cos theta is equal to cos alpha and secant theta is equal to secant alpha. We'll have the quadrant diagram like this, and the values of general solution of theta is 2n pi plus r minus alpha. And for tan theta is equal to tan alpha and cot theta is equal to cot alpha, the solution is theta is equal to n pi plus alpha, and the quadrant diagram is plus minus plus minus. So it's always better to remember the quadrant diagram as well as the solution, because if you forget the solution from the quadrant diagram, you can get the solution itself.